Hey guys, welcome back. I'm super excited to start this brand new chapter about Hive, one of the widely used tools in the Hadoop ecosystem. So far, we know how to write MapReduce programs using languages like Java. And we also saw Apache Pig, which made our lives much easier to work with Hadoop. Hive makes it even more easier to work with Hadoop, and we'll talk all about it in this chapter. Before you start this lesson, make sure you complete all the assignments from the previous lessons. I strongly suggest you to do so because practice what you learned solidifies your understanding of all the concepts you're learning in this course. Alright, in this lesson, we're going to see a brief introduction to Hive. And we're going to create a Hive table and query a dataset using the newly created Hive table. Sounds like a plan? Let me start with a question. Forget about Hadoop for a second. When we think of analyzing data, what immediately comes to your mind? For most of us, a database or a table comes to mind. It's not a surprise because we're so used to visualizing data in a table format, that is in a row columnar fashion. And also, almost all of us are familiar with SQL. Data in Hadoop cluster is represented as files, and so far MapReduce programming or PIG doesn't allow us to view the data in a table format. So it is only logical to have a tool in Hadoop ecosystem to represent the datasets in table structure and run SQL queries against it. Hive does exactly that. Hive was developed by Facebook and is now a top-level Apache project. Just like Pig, it is also widely used in the industry. With Hive, you can create table structures for your dataset and then write SQL queries to analyze your dataset. That's every data analyst's dream, right? And because of its ease of use, it has a very short learning curve when compared to MapReduce programming and Apache Pig. Hive takes in a SQL query and converts the query into one or more MapReduce jobs and submits the MapReduce jobs to the cluster. If you recollect, Pig does something very similar too. Pig takes in a Pig script written using Pig Latin and convert it into one or more MapReduce jobs and submit the job to the cluster. So why do we need to have two tools, Pig and Hive, doing somewhat similar things? First of all, Pig and Hive were created by Yahoo and Facebook respectively to solve the same problem around the same time. The capabilities of each tool was not fully transparent to both companies at the early stages of development, which resulted in the overlap. So the next question you might ask is, do companies use both Pig and Hive at the same time? The answer is yes. We have seen successful Hadoop implementations using both Pig and Hive in the same environment. Here is one such use case. You can use Pig for standard nightly extract, transform, and load, that is, ETL kind of jobs, doing predefined aggregation, data cleanup, filtering, and structuring of your data, etc. And Hive can use by developers, data analysts, and scientists on a day-to-day basis for ad hoc analysis of data. Just like Pig, Hive is also a client tool, meaning you don't need to have Hive installed on all the nodes in your cluster. It must be installed on nodes where the Hive queries will be initiated from, and that node should have access to the Hadoop cluster to execute the MapReduce jobs. That is the comparison between Hive and Pig. Now that we know Hive has the concept of tables and queries, let's look how does Hive compare to the traditional RDBMS systems. Hive leverages Hadoop for processing and hence can process huge volume of data. That is the strength of Hive. But Hive is a batch processing tool because it executes MapReduce jobs in Hadoop cluster behind the scenes. So you will not find all the bells and whistles of a traditional RDBMS system in Hive. Here are some of the key distinctions you will find when comparing Hive and a traditional RDBMS system. You will not find pointed updates or deletes in Hive. Hive has limited support for indexing and very high-level transaction support, which was introduced very recently. And there are no support for triggers in Hive. Those are some key distinctions. You should not see Hive as a database system, rather you should see it as a tool that helps developers write MapReduce jobs in Hadoop cluster using simple SQL queries. In the Hadoop ecosystem, Hive is a powerful tool. To start with, it makes MapReduce very easy. You don't need to know a programming language to write MapReduce programs anymore. All you need to know is SQL and you feel right at home when you work with Hive. It is easy to implement joins using Hive. Again, the query syntax for joins is just as same as you would see in a traditional database system. Hive helps in structuring the data efficiently with the help of partitions and buckets, which helps in optimized execution of your queries. Hive supports not just text, but different file formats. The next feature is very important when compared to database. Hive does not enforce the schema on the data that is stored behind the Hive table. For example, if you have a 10-column table in a traditional database system, when you insert a record into the table, you have to supply values for all 10 columns. And this means that the traditional database system enforces the schema during the write operation to the table. In a big data environment, our data may not always conform to a structure, and Hive understands that. So Hive does not care about the structure of the data and does not enforce the schema on write, whereas it only looks up the schema during the read operation, which helps us to work with data which are not fully structured. Finally, for any developer who wants to work in Hadoop, Hive is not an optional tool. It is a must-know tool in the Hadoop ecosystem. We will learn all the concepts in detail that makes Hive so special in this chapter. Before we look at all the details and all the important concepts, why don't we start simple? Let's create a database and then create a Hive table and query our stocks dataset. Sounds like a plan? Here's the syntax to create a database and a table. If you have worked with any databases like MySQL, SQL Server, or Oracle, etc., this syntax will be very familiar to you. To create a database, all we have to say is create database and specify a database name. Let's name our database stocks_db. Then to create objects under the database, we need to switch to the database. So we will say use stocks_db. Here is the syntax to create the table. You're creating a table with name stocks_tb by specifying a list of columns along with its data types. As you can also observe that the data types does look like data types from Java. There are a couple of new elements in the syntax which you will not find in the regular table creation syntax when you work with regular databases like MySQL or Oracle. Our stocks dataset is a comma delimited dataset. So, row format delimited fields terminated by comma here indicates that the columns in the dataset is separated by comma. The location attribute points to the location of the dataset in HDFS, and that is where the stocks dataset resides. The stocks dataset is the same dataset which we used in MapReduce and Pig lessons. Each row in the dataset has information like opening, closing, high and low prices, and volume for a stock for a given day. The other thing you will see is that the table is marked external. We'll look at table types in more detail in the later lessons. Now let's see how to execute this script in our cluster. Just like the grunt shell in Pig, Hive offers an interactive shell where you can execute Hive queries. Simply type Hive and enter in the cluster to enter the Hive shell. Here you can type in Hive queries. Let's now create the database and the table. Let's copy the create database instruction here. Let's execute it. The database is now created. So now we're going to switch the database to stocks_db. So any objects we create after this will be created under the database stocks_db. Now let's go ahead and create stocks_tb table. There you go, the table is now created. This table is pointing at location user HRW input stocks, and this is where we have our stocks dataset. So now what I'm going to do is I'm going to run a simple select limiting the number of records to just 100. Let's run this query and see the output. There you go. It's very simple, correct? We now have successfully created a Hive table and queried it just like you would query a table in MySQL or Oracle. It is liberating, isn't it, to view the data in a table structure. In the next lesson, let's dissect this table and we'll see what is involved behind this table. With that, let's wrap this lesson. See you in the next lesson.